Hey guys, welcome. Today we're going to talk about section 3.3, which is looking at the slope of lines. All right, so the first thing is, what is the slope? Well, the slope of something is going to be how it changes, your rate of change. And in this case, it's often called the rise over run. So it's how the y's change, the rise up and down, versus how the x's change, your rise over run. And that tells you the steepness of your line. So something with a large slope is going to have a steep line like this, versus something that had a small slope would have a less steep line. So this line would be very steep, hard to climb up. This one would be more of a shallow line. All right, so if we want to actually find the value, one way to do this is looking at the equation m is equal to your change in y over your change in x. So m is your slope, and then your change in y is y2 minus y1 over x2 minus x1. So let's actually plug this in and try to find some equations. So if we want to find the slope of line P, so that would be this right here, the slope of line P. So P has the ordered pairs. The first one is 1, 1, 1, 2. 1, 2 is one of the ordered pairs. And then the second ordered pair is negative 2, negative 2. All right, so we just picked 2 points on this line. They were already given to us. All right, so once we know that, we can then figure out which point is which point. So one of these points we're going to call point 1, and the second one we're going to call point 2. It doesn't matter which one. If they switch, they're switched. This is just like when we were finding the distance between 2 points, and we had to call one x1 and the other x2, and then do the same for the y coordinates. We're doing the exact same thing here. So for this, we'll call this one x1 and this one y1, x2 and y2. All right, once we get that, we can plug these points into our equation over here. So we know that the slope is equal to y2 minus y1. Well, y2 here is negative 2. Negative 2 minus y1, which is 2, all over x2, which is negative 2, minus x1, which is 1. All right, so this is equal to negative 2 minus 2 is negative 4. And then negative 2 minus 1 is negative 3. Your negatives cancel because negative divided by a negative is a positive. So you are left with a slope of 4/3. All right, that's for line P. If we wanted to find line Q, so this line right here, Q has the ordered pairs negative 3, 2, and 2, 0. All right, pick one of your points to be x1 and the other to be x2. So y1, x1, y1, and x2, y2. And then plug that into your equation. And let me draw a line here so we don't get these confused. M is equal to the change in y's. So y2 is 2 minus y1, which is 0, all over the change in your x's. x2 is negative 3 minus x1, which is 2. All right, so now we have 2 divided by negative 5. And that one does not simplify. So then the slope of our second line is 2 over negative 5, or negative 2/5. All right, this is the exact same thing. So if I wanted you to determine the slope of a line that contains these 2 points, you're doing exactly what you did up here. This is a line that contains 2 points. So this is finding the slope of this. Oh, and if we want to, let's go through this real quick too. So a negative slope is going downhill. A positive slope is like going uphill. So notice with the green one, our green line, line P, it is a positive slope. And so if you were going to go from left to right, so if you were going to go up, you're traveling uphill. And you can also look, I also said this was rise over run. So what you can do is 4 over 3. So you go up 4 over 3. Well, if you go 1, 2, 3, 4, up 4, and then over 3, 1, 2, 3, you get to that second point. Now, realize that any point, any place here will be a point on your line. But if you're trying to find 2 points, one way to do that is going up 4 over 3, and there's another point right there because of the slope. For 2 over -5, that means that you're going up 2 and then to the left 5, or you can go down 2 and then to the right 5. 1, 2, 3, 4, 5. So down 2 and then to the right 5. Rise, since you have a negative number, you actually go down, you don't go up. So for this guy running along, he's going downhill. So this guy has a negative slope. And this guy over here has a positive slope. M is equal to 4 over 3. All right. So we're looking at this. If we want to find the slope that contains 2 points, we do the exact same thing. M is equal to, let's say this is point 1, so x1, y1, and this is point 2, x2, y2. So M is going to be the change in your y's all over the change in your x's. All right, now realize this comes from one point and this comes from the other point. All right, so from the second point, we have y2, which is -2, minus y1, which is a -2, all over x2, which is 6, minus 1. The negatives cancel and become a positive, so we have -2 plus 2, which is 0, over 6 minus 1, which is just 5. Well, 0 divided by 5 is 0. So this one has a slope of 0. If you were going to graph a slope of 0, what does that look like? Well, it has no rise and has all run. 0 over 5, so you're not going anywhere. You're not going up anywhere, but you can still keep going this way. So it would be a flat surface like this. For this one, x changes, but what does the y stay at? -2. So the y is always at -2. So no matter where x is, y is -2. So this then is the graph y equals -2. If you had one that was like this one, the slope is undefined. And it's undefined because you have some number over 0. Well, when you divide a number by 0, you get an error. That's called undefined. The error means it is undefined. All right. So this one has a slope m equals 0. And when you have x equals some number, slope is undefined. All right, so now we determine the slope of example 2 as being 0. Let's go on to example 3. If we're going to graph a line with the slope of 4 that passes through 6, 2. Okay, so now we know what the slope is and we know where it passes through. We want to graph the line. So one way to do this, let's go to 6, 2, 1. So you go to the right 6, 1, 2, 3, 4, 5, 6, and then up 2. So this is the ordered pair right here, 6, 2. All right, and if you're going to graph it with a slope of 4, m equals 4 is really 4 over 1. And so that means rise 4, run 1. So you're going to go up 4, 1, 2, 3, 4, and over 1. You can do the same for down here. You can go negative 4, 1, 2, 3, 4. And if you go negative 4, you have to go back 1 to stay in the same line. All right, so then this is going to be your equation. That's going to be your line. All right, another thing that we want to talk about with this, which leads more into the geometry of this part, because I know this is an algebra review. But we want to look at these two things. So if lines have equal slopes, so this would be one slope. If they have the same slope, what are these lines? Parallel. So these parallel lines have equal slopes. All right, if lines have negative reciprocal slopes, or the product of their slopes is -1, you can look at it either way, then these lines are called perpendicular. The symbol for perpendicular is like this, like an upside down T. And what do we know about perpendicular lines? They form right angles. They form right angles. Okay. So if we're going to find the perpendicular slopes for these given slopes, you would take the negative or the opposite reciprocal. So the opposite would be a negative value, and the reciprocal is 1 divided by 2. So you flip the top and bottom. This is really just like 2 divided by 1. All right, for this one, you take the opposite, so negative, now it's positive, and then you flip the top and bottom, so now you just have 3. For this one, you make it negative, you flip the top and bottom, so it's 5 over 2. This is really 1 over 1. So you make it negative, you flip the top and bottom, you still have 1 over 1, which is just equal to -1. And the cool thing is if you did the product, so you multiplied, product means multiplied, multiply their slopes, you get -1. So 2 times -1 over 2, well, your 2's cancel, and you're left with -1. And you can do, that's what multiplying by the reciprocal, opposite reciprocal means, is your this product of the two is going to be -1. All right, so down here we want to determine if A and B are parallel, perpendicular, or neither to CD. All right, so one thing that you can do is if we look at the chart, so if we had plotted all these points and looked at the chart, we could tell by the chart how many do you rise. You go up 1, 2, 3, 4, 5, 6. You go up 6 over 2, which means that AB has a slope of 6 over 2. Rise 6 over 2, which is just equal to 3. For CD, the slope is going to be up 2 over 1, 2, 3, 4. So up 2 over 4, which simplifies to 1/2. You could also, if you didn't graph it out or you didn't want to look at this way, you can also do it looking at the slope equation. So A and B are your 2 points. So x1, y1, x2, y2 for this line here, AB. So these are your 2 points. So plug these in. So change in y's is 5 minus a -1, which turns positive, all over 1 minus a -1. And when you subtract a negative number, it's just like adding. So this is really 6 over 2, which is just 3. So you can do it either way. If you had graphed it out, you could draw it out and then find the slope that way from the graph. Or you can use the equation change in y over change in x, rise over run, to find your slope that way. Okay, so you get these 2 slopes. But now we want to know if these are parallel, perpendicular, or neither. Parallel, perpendicular, or neither. Well, this one is 3 and this is 1/2, so are they parallel? Well, for it to be parallel, they have to have the same slope, so that's not right. They're not parallel. What about perpendicular? Well, to be perpendicular, they have to have opposite reciprocal slopes. Or if you multiplied them together, you would get -1. Well, 3 times -2 is 3 over 2, which is not equal to -1. They're not perpendicular, so these are neither. And you can see that in the graph. So these 2 lines, they intersect, so they're not parallel, and they're not perpendicular because this angle right here is not 90 degrees. If this angle was 90 degrees, they would be perpendicular to each other. All right,